So we'll see. I said I might just end up having to take off work early tomorrow. And
What do you do?
I work in mental health. I kind of manage the front office. We take care of all the doctors and get the new clients in and enrolled and try to keep everybody from killing themselves out in the lobby. And
Wow. Exciting.
I've got a staff of like 7 that I manage as well.
Well, here we go. For question 2, I got a randomly selected brand of toothpaste at a convenience store.
Yep, that's what I got.
Okay. Okay, mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements are true? 100 is a parameter. Actually, that is true.
Yep. I also got 112 as a statistic.
Yep. So that we both agree on. Okay. Rotham City has 4 distinct neighborhoods. The property values are similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. Just a second. Hang on. The box in your hand, honey. You just need to go up a little bit. Your backpack is right there. There's your backpack. See, isn't that your backpack right there? Yeah, Teddy B's in your backpack. Now go up to bed. Sorry.
Oh, no, you're fine.
Yeah, okay. So I thought that they should be using a stratified sample. What did you think?
I got simple random sample. These are the ones I was like.
Okay, well, all right. So here's why I don't think it's that. Because what we want to do here is we want to get something that's pretty representational of everything, right?
Yeah.
But each neighborhood has, like within the neighborhood, the property values don't vary very much. But between the neighborhoods, they really, really do. So wouldn't you have to have it by a stratified sample, grouped by similar kinds of things to make that work?
Yeah, this is one. I think I chose stratified in the beginning, and I said I would see what you thought, depending on my final answer, because I was torn. So I think I'll go with stratified as well.
Well, the one I don't know where I don't know where Steffi is, baby. You're just gonna have to go look in the other room. Good night, Margaret. Okay, usually there in bed. Okay, so I chose stratified for that. But then, okay, the next one, when designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all of the students in the selected classes. Which time of sampling scheme is implemented? I thought that was a cluster sample, but maybe not.
I also put cluster sample.
Okay. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Hold for one moment. Sorry about that. Hold for
no
one
problem.
Stand. Help.
Girl, it's like 5:09.
Tell me about it.
Stuart.
School? What class is it?
Statistics.
Ooh, yeah, that was not my favorite.
You're welcome.
I appreciate you. Lock yourself back in your home.
Okay, thank you. All right, sorry about that. I thought everybody had went home for the day.
So you do this at work?
Yeah, normally, because we're normally closed by 5 anyway, so I'm like, eh. And my webcam at home is normally iffy.
Okay. All right. Well, so on the PTA one, I just said a simple random sample.
Yep, that's what I said.
Okay. The next one is the Wolves and the Republicans. So to me, that isn't that a cluster. They take the Republican cluster and they take the Democrat cluster.
I chose stratified because the definition states that it would take normal random samples or
Okay.
simple random samples. So that was the reason I chose stratified for that one.
Okay. All right. Okay, so then we come to the Crossroad purchases XLX1. And I'm going to just, you're not really gone, okay? I'm just looking at it on the,
Oh, you're fine. I can't see you either because I got my page up.
okay. So if we have the Crossroad purchases and the quantitative statistics thing open, I just filled it in with that little thing. And the mean that I got was 4.771.
Yep, that's what I got.
Okay, so we agree on that. We're going to get to the one that I'm really confused on not too long from now. Okay, calculate the standard deviation. And again, we got to use the software, so I had 1.911, which is really 1.912 because of the rounding.
Yep. Yeah, I got 912.
Whoops, hang on a second. I'm seriously worried about this test, even though we get a cheat sheet, right? Okay. Then,
Yeah, I've yet to put that together either.
well, I've started to. Okay, then it says create a histogram of the amount spent in Crossroad purchases and mark the following statements as true or false. Well, I did create a histogram because it's really easy. It just did it automatically.
Yeah, I used that thing too.
So, and that was really it, right? I mean, because the machine did it. We didn't, you know?
Yeah.
The QQ plot we would have to actually go in and create, but this one it just does. Okay, so now we have the seals. So, okay, I actually worked this out on a little table. Okay, so let me close this or minimize this so I can get back to where I have the seals. Okay. So for the first one, for thing A, I had 0.0272. So I don't know, what did you end up with?
For number 11, I got negative 0.165.
Okay, wait, you're right, because, yep, I moved it over one. Okay, I forgot to write one column on my paper. This is why I'm going to not do well on this test tomorrow. Okay, let me just, I actually got that same thing. I just had to read the right column. Hang on a second. Negative 0. Okay. And then the position B, I have to go back up and look at what is position B. Okay, that's, all right. So for position B, I had 0.6806, so 0.681.
Yes, that's what I got.
So either we're both going to get it completely right or we're both going to get it completely wrong.
Yeah.
Just saying.
Hopefully completely right.
Okay. What quantity is equal to the sum of the numbers in the squared deviations column? None of those are.
I got the variance. I don't know why, but
Oh, I don't think it's a variance. I'm going to check something really quick. Hang on a second. I'll be right back.
okay.
Because I think that isn't the variance. Because I think they define the variance in lesson 3 in a different way. Just a second. Because when they went through this little chart, okay, so in lesson 3, they go through, you know, they actually, hang on a second. Okay, so they say that, all right, so you get, you know, you add a third column to the table, which we did. Now add up the squared deviations from the mean. But to get the variance, the sample variance, you divide the sum of the squared deviations by n minus 1. And I don't know if the variance itself is actually the thing that we're calculating in column 2, I think.
Yeah, if we were to calculate it out, I basically just went by definition for this one that the sum of squared deviations from the mean is called variation. So I don't.
Okay, well.
Not sure about that one.
Well, you know what? You went by a definition and I went by an example, but it's probably the definition. Okay, yeah, there's a difference though between the variance and the sample variance, so you're right. The variance is the sum and the sample variance is the, okay, we're good, probably. What is the standard deviation of these temperatures?
I got 0.715.
Okay, well, I think I'm trying to find where I did this actually. Okay, so if we had, the standard deviation is going to be, that's the sample variance. Okay, the square root of the sample variance, all right, okay. So the sum of the sample variance, or the variance was 1.5371, and then we divide that by n minus 1.
Mm-hmm.
What? So in this case, that'd be 1, 2, 3, 4, that'd be 3. And then we, okay, and then we take the square root of that, right?
Yeah.
So I'm going to just, you know what? I can see some value in doing this because when I actually talk it out loud, I actually understand what I'm doing a little bit better. So you got 0.716?
I got 0.715.
Okay, so because it's 0.7, I got 0.7155.
Okay.
But don't go by me particularly. I mean, because
I couldn't remember the rounding thing of 5 if I rounded up or down, but if you got 716, I'll go with that.
Well, that's what I would get if I rounded it.
Yeah.
Because it's 7.71554, so I would say it's 0.716. And if we get it wrong, then we know that it was actually 715. Okay, under certain conditions, the standard deviation can be negative.
I got false for that.
Yeah, you know what? This confused me last time because I put true because under certain, in a graduate statistics class, in fact, it can be negative, but for the purposes of our class, it never is. So it sort of bugged me. Well, anyway. So, all right. In the same study, the researchers, okay. All right. So which location resulted in the most consistent temperature measurements from one cell to the another? I put extradural because
yeah, that's what I got.
Because the standard deviation is the tiniest.
Yeah.
And that's what this is supposedly measuring. Okay. Next, we have the dreaded bar and whisker plots. But the
I know,
third,
I hate those.
okay, so, but the third quartile is actually going to be, what, 8?
Yeah, I got 8 for that.
Yeah, okay, so I'm not a fan of these charts, just saying.
Yeah, I do not like box plots at all.
Okay, and then the percentage of data lies between 4 and 8 hours. So to me, it looks like 50, but
Yeah, I got 0.5 and changed that to 50 for 50%.
yeah, this is another thing that it's really hard to tell. But yeah, I think it was 50. I don't know. Okay. All right. The next ones, to be honest, I'm very confused about. Because I had a hard time with this the first time we did it too. So, yeah, so here we go. Okay, this is a normally distributed population, right?
Yep.
And we don't actually get a mean anywhere. I mean, they don't tell us the mean. We just know it's between 2.52 parts, but anyway. So estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Seriously, I don't even know how to approach this.
Yeah, now I've looking at it, I forgot how I did it the first time. Let me see if I can.
I don't know that I actually know how to do it. I mean, it's between things, so I kind of wondered if it was like the thing between Z1 and Z2. But we don't know sigma, and we don't know. All we really know is X. We don't. And I don't know how to estimate the standard deviation for the same reason. I really just don't know. There's a part of me that says I should just come back and do those.
Which my paper that I work stuff out on is actually at home, but I got an answer for this of 2.055, but I'm trying to figure out how I came to that.
Okay, see, because what I was thinking about, I mean, you can, in regular math, not statistics, you could solve this as a simultaneous equation, because if you added the two equations together, but then you get the mean as 2.55. And
yeah, that's what 2.055.
You got what?
2.055.
Yeah, but that's not what I got. Well, I could have done it wrong. Hang a second. Let me do it. I mean, I was working it out on paper while somebody was screaming at me, "Grandma, I need some help." So hang on a second. Yeah, 2.055. Yeah, you and I solved it the same way. Because that was the only thing I could think of. Okay. So, all right. Yeah, because I solved it that same way. All right. So then, all right. So we have the mean there, and then they estimate the standard deviation. So since we have the mean, we should be able to just plug the mean back into one or the other of these equations, and it should just be the same, right?
Mm-hmm.
Plus 2 times 2.055 equals 2.52. Okay, so it's going to take me a minute, and then I'll see if I come up with the same thing as you. Okay, wait. So the mean is 2.055 plus 2 sigma equals 2.52. did you come up with 0.2325?
I got 0.658.
Okay. All right. So how did you get the standard deviation? Okay, I'm going to try it the other way. So if I have if I add I'm just doing it again and with the other one. I still get 0.2325, so 0.233 is what I still get that, because I just solved for it with the equations that we were given, basically. Like I essentially solved for it as an algebraic. You know what I mean?
Yeah, yeah.
I just did it as an algebra thing. And because I get that, because we know that sigma is the same either direction that it goes, the value is the same. And I got the value when I solve for the equation, I get the same sigma value for either of the two equations that I have. So you probably did it right and I probably didn't, but okay, so 68% of them are going to lie within one standard deviation away from the mean, right?
Mm-hmm.
So if we got 2.055 as the mean, one way we can check this is just to see if any of these answers come out right. So I can go down here and look and see if any, yeah. And if I add, okay, so if I substitute the number I got that I found, then in question 21, answer D, or the last one, 1.823 and 2.288 makes sense, because 68% is like one standard deviation away, right?
Mm-hmm. Yep.
So if you plug in the number you got into what we know from the mean and subtract it, do you get any of the answers that are on here?
I got close to it. I got the first one close to it, but I was off by, I got like 1351 or something like that.
Okay, because mine came out to be exactly these. Well, we each get to choose.
Well, if you got an exact one, I'll go with that, because like I said, mine was off. And
well, so I know, but the way I estimated the standard deviation was different than you. Because I went to 0.233.
yeah, that's what I was saying. I would just change my deviation if you got a.
Well, I don't know if I did it right though, Mary. All I did was solve it algebraically. I don't know if that's right or not. I guess we'll find out when we submit it. I'm going to hate this test tomorrow. I can tell. Like I'm going to go through it again tomorrow morning and spend a lot of time on it tomorrow, but anyway. Now we move into stuff that's relatively recent, so we should be okay. I hope. I think they give us the applet in here somewhere, right? Or they tell us we can use the applet up at the top.
Yeah, up at the top.
Because I think we can use the applet and we can use that nifty cool Excel thing.
Yep, we can.
Okay. So zipping right down here. I guess one thing about this is, you know, we are doing this early enough that if we don't get it right, we can go back and study it some more and try to get it right on the second one.
I know, because the ones we just answered, I'm going to definitely have to go back and rework those so I can figure out what I did the first time.
Yeah, okay. Well, I'm just skimming down here for a second. Okay, so I'm now, okay. So now, how many questions are on this thing anyway? Oh, 32. No, 31. Okay. Well, all right, so we know here, all right, so we got a bunch of GMAT score information. Okay, so the mean, mu, is 542.3. Standard deviation sigma is 120.54. Minimum GMAT to get into this program is 500, but that's kind of, I don't know. And then 600 is the usual admission score. So this is a tough program. Okay. Okay, what is the probability that a randomly selected student will score above 542.3 on the GMAT? So we have to do the z-score. Let's see. Well, wait. How do we? 542 is the mean. So all we have, yeah. So we would figure out. That would be like 50% of them, right?
Yeah, 50. Which I got like 0.500.
Yeah, okay, so hang a second here. I'm just seeing. Okay, so yeah, because it's the mean, that's the middle. So, you know, half of them are going to do better than that, and half of them are going to do worse than that. Okay, so then the next one would calculate the z-score. So then we would have, I got to stop and think about the formula for that for just a sec. Okay, it's x minus mu over sigma, right? Okay, so then if we have x in this case is 600 minus 542.3, is this how you did it?
Yeah.
Get, and then divided by 120.54. So then 600 minus. Then 1, 2. So then for the z-score, I got 0.478679, bunch of stuff like that.
Yep, that's what I got.
Okay, so they don't really ask us that, but we can then use the little applet number. So we would go to oops. And since it's below 600 and that's above the mean, wouldn't it be 0.6840? Is that what you got?
Yep, that's what I got.
Okay. Well, it's only 3 things, but then we should be able just to subtract subtract 0.684 from 1, right?
Uh-huh.
So I got 0.316.
Yep, that's what I got.
All right, so the nifty cool thing about this next one is the GMAT score that corresponds to the 10th percentile. So then we have to actually do it, reverse the formula basically. So we go in, or how I think we do it is we put in 0.10 on the applet. And because that's less than half, then the z-score would be minus 4.79. Is that what you got for the z-score?
I'm not sure. I'd have to rework it.
I'll tell you what, I'm going to just go back and plug that in as if it were the z-score. And if I'm wrong, if we don't get the same thing, then we can rework it together. So x minus the mean, which is 542.3 over 20.54. So we multiply both sides by 120.54.
I got 1.282 for the Z-score.
Okay, you got 1.282 for the Z-score?
Uh-huh.
How did you get that? Because
I just put 0.10 up at the top and shaded.
yeah, but which part of it did you fill in? Because 10% is going to be under the 50th percentile, so wouldn't it just be that left chunk?
Yeah, I did the left side. It gave me 1.282.
Really? Okay,
Mhm.
I need to do it again then, because I got 0.10. And what did you say you got?
1.282.
The Z-score?
Uh-huh.
But the area would be the 10th percent. Oh, I see. Oh, okay, I see. I wonder what happened when I did this the first time. That is really, really weird. All right, I'm going to do it one more. Okay, I agree with you, actually. I have trouble with this applet because sometimes it doesn't reset.
Yeah, I normally will refresh my screen.
Good plan.
I've done that before.
What?
I've done that before, so I'll normally just refresh my screen.
Well, you know what? I think that's really smart. I'm going to remember to do that tomorrow because this applet is really terrible about, yeah. Okay, so now I'm just going to 1.282 multiplied by. Did you get 387.76?
I did.
So I think then we round it just to the whole number, so that'd be 388. And that's actually a pretty crappy, well, all right. If this is a legitimate, if this is really true to the thing, that's just a really bad GMAT score, just saying. Okay.
Yeah.
I used to work for a graduate school. Okay, for a graduate school of business. All right. Okay, so now the next one is the 90th percentile, but that's going to be the middle one and the other one, right?
Uh-huh.
But the Z-score is still 1.282, right?
Yeah.
Only it's positive 1.282.
Yeah.
So if I'm sure glad you're my group partner, and I sure wish I knew what happened to Ashlyn.
Yeah, I know. It's just strange. We haven't heard anything.
I'm actually going to text her. I tried doing that and didn't get an answer earlier. But I'm going to try texting her and just see, what's up. Okay. So I got 697.
Yep, that's what I got.
Just a second. Stupid phone. Oh. Okay, then the first quartile is going to be the same concept, but it's going to be it's going to be only the other half, right? Because did you get negative 6.74 as the Z-score?
I did.
Okay. 0.674, because that matters. Well, it explains a lot that you're doing this at work, because I looked at your thing, your background, and I thought, wow, she has a really nice home office.
Yeah, I'm normally just sitting on the couch doing the homework.
Okay.
because my little one's daycare is like 5 minutes away.
Uh-huh.
So I normally just meet and run down the street and pick her up.
So did you get 461 then for the 25th percentile?
I did.
Okay, so either we're both doing this correctly or we're both really messing it up. Okay. I think
Hoping
though
it's the first one.
what?
Said I'm hoping it's the first one.
I actually am pretty sure that it is because we have been pretty consistent on this last batch of stuff. We've done pretty well. We seem to understand this one better. Okay. And you had the same z-score, right?
I did. Yep.
Yeah. Okay. It's just positive instead of negative. Too bad we can't do groupthink for the test.
I know, that would be nice.
I know why they don't do it, but still. Okay, so I came up with 624 for the other one.
Yep, that's what I got.
Okay. Okay, now we do the other version of the z-score thing. N equals 15. But the thing is, the mean is the same.
Uh-huh.
So I have to go back up here and find the mean because I forgot what it was already, but
It's the 542.3.
yep. You know, I've written that down like 500 times now. No, but every time we've done it, but you would think I would remember, but no. Standard deviation of the sample mean for all such samples. Okay, I have to stop and think this through because I don't remember the formula. Hang on just a minute. Do you remember the formula?
I'm trying to find it now.
Yeah, I'm just trying to remember it's less than, okay. I got it. It's, okay, so the z-score is, all right, let's see. That's the value minus the mean over the standard deviation, which for the case of this is x bar minus mean sigma divided by the square root of n. So it's not so bad as that. Okay, so what is the standard deviation of the distribution of sample mean scores for all such samples? But we don't know. I'm trying to remember. Okay, the distribution of a sample, yeah, that's sigma divided by the square root of n. So
I got the 31 point.
well, I'm still trying to figure
1,
out.
2, 3.
Okay, I'm still trying to figure out the whole thing. Okay, so all right, so we have the standard deviation of the regular thing, right?
Mm-hmm.
So that's like 120.54. 20.54 divided by the square root of 15. My thing is I've got to figure out how to put this on here on my one sheet of paper.
Or to just write small. Which I was just typing mine. I've been typing some things and I'm like, I'll just make it a really small font.
You know what? I probably ought to do exactly that same thing because 31.123, so 31.1232.
I just did the 1, 2, 3 for the 3 decimal places.
Yeah, that's what it was going to be. But anyway,
Yeah.
hang on just a second. Whoop. Okay, what is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600? So then we need the z-score. So the z-score is 600 minus 542.3 over 31 point whatever we just got. So 600 minus 542.5, 57.7 divided by 31.123. So for the z-score, I got 1.8539.
Yeah, I think that's what I
1.85.
got.
Okay, so then I have to plug that into the nifty little applet. My husband, when I was kind of whining about this a little bit, my husband says to me, you know, it could be a lot worse. I said, how could this be a lot worse? He said, they could have you do the calculus to calculate the area under the curve instead of just do, I was like, just be quiet. Okay, so I have 0.0319, so 0.032.
Yep, that's what I got.
Well, I guess we save all responses and see what we missed. And then I study like crazy on all the stuff that I missed.
It looks like we only missed one.
Yeah, I'm kind of surprised, right? Oh, we could.
And it was the one I said was right, so you're probably right with the none of these is correct.
Well, you know what? That's what I just thought it was. Is that the one we missed?
Yeah.
Okay, so I'm pretty sure. Well, I'm not 100.
And it's so funny because I did the none of these is correct originally, and then I looked it up, and it was saying the variation, so I went with that.
Yeah, and yet when I was looking at the process, it was like, no, the variance is actually, I thought the variance was x bar minus the mean. So it is the none of these is correct, I bet. Don't you think so?
I think so, yeah.
All right, well, friend, I'm going to come back and look at your smiley face for a minute. Good luck tomorrow.
Oh yeah, good luck to you too. We'll have to tell each other what we, well, I wonder, it should give us a grade as soon as we do it, so we have to let each other know what we did.
Well, hopefully we're as good by ourselves as we are together.
I know, I just get so confused on all the different formulas, and I'm like, okay, I need to figure out what goes where.
Yeah, yeah. And it's sort of disconcerting, right? Just, yeah. And you know what? I could go back and do this over and get 100, I guess. But I think I'm going to be okay with it when it is, because I'm pretty sure the answer to that was it isn't any of those. Because I know it isn't the other three.
Yeah.
So I'm pretty sure the answer is just it isn't any of that. So, well, I hope it goes well for you tomorrow.
I know. We'll pray a lot and pray for each other.
I'll pray a lot. I'll pray for you too. And then I guess we have another one of these suckers due on Thursday.
Yeah, do you want to try to, well, we could just meet Thursday afternoon.
Let's just meet Thursday, because I think we're going to be pretty burned out after the test tomorrow.
Yeah. Thursday, same time works for me.
All right.
Okay, see you then. Good luck.
Thanks. Good night, Mary.
Bye.
Bye.